Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLD College of Science, Akola. Dear student, in previous lecture we have seen some problems on an integral. So in this lecture we will see some another example on an integral which containing term, that is integral 0 to infinity f of x dx. Okay, so on this topic we will see some problems, some problems on integral 0 to infinity f of x dx. Okay, so problem number 5 is show that integral 0 to infinity x to the power minus c 1 plus x dx equal to pi upon sine pi c, where c lies between 0 to 1. Okay, so this is the problem. Now we will see the solution of this problem. So let us consider f of z function can be defined as z to the power c 1 plus x in the form of z. Okay, so here clearly z equal to minus 1 is a simple pole of f of z and z equal to 0 is the branch point. Okay, so select the closed curve gamma as, so this is the closed curve gamma. Okay, and this is the gamma r inner closed curve. Okay, so circle gamma r, that is mod z equal to r, so which represent a circle whose center 0 and radius capital R. So this is the outer circle, which is the curve is gamma r and radius is capital R, center is 0. Gamma r in the anticlockwise direction. Second, along x-axis from r to small r. Along x-axis small capital R to small r, or small r to capital R. Okay. Third, circle gamma r, that is mod z equal to r, in clockwise direction. So let us consider this inner circle whose curve is gamma r, which is clockwise direction. So therefore along x-axis from small r to r, as r tends to 0 and capital R tends to 0. So by using the concept of the integral type, so integral or curve gamma z to the power c 1 plus z dz equal to, first curve is integral or curve gamma r z to the power c 1 plus z dz, plus second curve, that is capital R to small r z to the power minus c upon 1 plus z dz, minus integral or curve gamma r z to the power minus c 1 plus z dz, and plus last is integral or small r to capital R z to the power minus c 1 plus z dz. Okay, so since here r small r tends to 0 and capital R tends to infinity, so let us consider equation number 1. Now we will find out the residue of f at a point minus 1. So therefore by using the definition of the residue at point f at a point minus 1, so this can be written as limit z tends to minus 1, z plus 1, this is the f of z value, z to the power minus c 1 plus z. So put z equal to minus 1, we will get minus 1 to the power c. So minus 1 can be written as e raised to power I pi to the power minus c, and this can be written as e raised to power minus I pi c. So by using Cauchy-Riesch's theorem, integral over curve gamma z to the power minus c 1 plus z dz equal to 2 pi I into residue of f at a point minus 1. Okay, into 1. So this can be written as 2 pi I, and residue of this is, that is e raised to power minus I pi c. Okay, so index of closed curve at a point 1 is at a point 1, that is 1, because the circle the point which is lies inside the circle. Second, consider the limit z tends to infinity z f of z. So putting the value of f of z, we will get z to the power c 1 plus z into z. So limit z tends to infinity z to the power c, so this can be written as, so taking z is common, so we will get 1 upon z plus z, z will get cancelled. Okay, so putting the value of taking the limit z tends to infinity, we will get a 0. Putting the limit in this, we will get 0. So therefore by second result, limit r tends to infinity integral or curve gamma z to the power minus c upon 1 plus z dz equal to 0 into I 2 pi minus 0, that is 0. So this will give the 0. So this is equation number 3. Now let us consider limit z tends to 0, z minus 0 at a point 0, z to the power minus c upon 1 plus z. So limit z tends to 0, we will get z to the power 1 minus c upon 1 plus z. So this z and this z to the power minus c can be written as z to the power 1 minus c upon 1 plus z. So putting the values of taking the limit, we will get a 0. Okay. So again by using third result, limit r tends to infinity integral or core z to the power c upon 1 plus z dz. So which will give that is 0. Okay. Equation number 4. Now we will use equation number 2, 3, 4 in equation number 1. Then equation number 1 will becomes 2 pi I e raised to power minus I pi c equal to, so this will become 0, integral infinity to 0. Okay. So putting the values 2, 3, 4 in equation number 1 and solving, we will get these steps. Okay. So 2 pi I divided by 1 minus e raised to power minus 2 pi I c equal to integral 0 to infinity x to the power c upon 1 plus x dx. Okay. So after this is the calculation part. After solving and calculating, we will get this step. Okay. Now we will multiply numerator and denominator as well as by e raised to power I pi c. Okay. So multiplying on both sides, we will get these steps and some cancelling and rearranging terms. Okay. So after solving these steps, we will get the required result, that is integral or 0 to infinity x to the power c 1 plus x dx equal to pi upon sine pi c, where c lies between 0 to 1. Okay. So this is the example number 5, integral 0 to infinity. Now we will see example number 6, that is here we have to find out the value of the integral 0 to infinity 1 minus cos x divided by x square dx. So let us consider the f of z is 1 minus cos z divided by z square. So this can be written in this form, 1 upon z square minus cos z upon z to the power 2. Okay. So 1 upon z square, so this can be written as e raised to power I z. Okay. So therefore f1 of z minus f2 of z. So here we will get two functions, that is f1 of z and f2 of z. So here f1 of z is 1 upon z square and f2 of z is e raised to power I z divided by z square. Okay. So therefore here we can say that f of z has a singularity at z equal to 0. Okay. So now we will choose the curve gamma as containing. So this is the semicircle, outer circle, and this is the inner circle. This is minus r2 plus r, this is minus r2 small r. So this is the curve gamma r, this is the curve capital gamma R. Second is segment along x-axis from minus r to capital R, minus r to minus r. Third is semicircle gamma r, that is mod z equal to r, image of z greater than 0 in anti-clockwise direction. And number 4 is segment along x-axis from small r to capital R, as capital R tends to infinity and small r tends to 0. Now let us consider the first function, that is f1 of z. Okay. So 1 upon integral over curve gamma 1 upon z square dz, integral over gamma 1 upon z square dz. Okay. So we will simplify this integral in this region. Okay. So index of closed curve at point 0 will be the 0, because z equal to 0, which lies outside of the curve gamma. So therefore the value of this integral will be 0. Equation number 2. Also limit z tends to infinity 1 upon z square. So which equal to limit z tends to infinity, z will get cancelled 1 upon z. So put the value of z equal to infinity, we will get 0. Okay. Similarly, the result limit r tends to infinity integral or gamma r dz upon z square. Okay, so this will gives 0 pi minus 0, so this will becomes 0. Okay, also limit z tends to 0, z minus 0 upon 1 upon z square, so it will give limit z tends to 0, z upon z square. Okay, so if you take the limit z equal to 0, so this will give the 0 by 0 indeterminate form. Okay, so to remove this indeterminate form, we will apply the L'Hospital rule. So by using L'Hospital rule, so taking the derivative of numerator as well as denominator. So derivative of with respect to z is that is 1, and derivative of with respect to z is that is twice z. Okay. So now we will take the limit. So putting limit z tends to 0. So we will get a 0. Okay. So hence limit z tends to r tends to r, integral or cor gamma 1 upon z square dz equal to 0. Equation number 4. Now we will use equation number 2, 3, 4 in equation number 1. Then equation 1 will becomes right hand side, that is 0, equal to first integral will become 0 plus second integral minus infinity to 0 dx upon x square minus third integral will become 0, and fourth integral 0 to infinity dx upon x square. Okay, so here we will get minus infinity to plus infinity, minus infinity to plus infinity we can write, that is 1 upon x square, 1 upon dx upon x square, okay, equal to 0. So this can be written as 0 to infinity 1 upon x square dx equal to 0. Equation number A. Now consider the second function, that is f2 of z. This integral can be expand in this term, integral over cor gamma e to the power as a dz upon z square. So this can be written in the along cor gamma r minus r to small r gamma of r and plus small r to capital R, where small r tends to 0 and capital R tends to infinity. In similar manner, we can write these steps. So now by using Jordan lemma, so here 1 upon z square tends to 0 when z tends to infinity. So therefore a limit r tends to infinity integral over cor gamma r e to the power I z upon z square dz equal to 0. So this is the equation number 2. Now by using again formula limit z tends to 0, z minus 0 e to the power I z upon z square. Okay, z minus a, that is z minus a means 0. Okay, so limit z tends to 0, so e raised to power I z upon z. Okay, so we will get, if you put the limit 0, we will get the indeterminate form. So again here we will use the L'Hospital rule. So by using L'Hospital rule, we will get the value of this term, that is I. So therefore which is equal to I. Now we will use this result, that is limit r tends to infinity integral over cor gamma e to the power I z z square dz, which is equal to I pi minus 0 into I. So this will becomes, that is minus I square that is minus 1. So that is minus I. So now since the singularity of f of z at z equal to 0 does not lie inside the cor gamma. So therefore by Cauchy-Residue theorem, integral over cor gamma e to the power I z upon z square dz equal to 0. Equation number 4. Now we will use equation number 2, 3, 4 in equation number 1. Then equation number 1 will becomes left hand side, that is 0, equal to first integral will become 0, second integral will become minus infinity to 0 e to the power ix upon x square dx, plus third integral will pi, plus 4 integral is 0 to infinity e to the power ix x square dx. Okay, so this can be written as, that is 0 to infinity e to the power ix upon x square dx, that is minus pi by 2. Okay, now here we will equate the real and imaginary part. So therefore integral 0 to infinity cos x upon x square dx equal to minus pi by 2. So therefore this can be written as integral dx upon x square minus 0 to infinity cos x dx upon x square equal to 0 minus pi by 2, and hence we will get a required result 0 to infinity 1 minus cos x upon x square dx equal to pi by 2. Okay, so this is the example number 6. So here we have completed all the examples which containing trigonometric function, integral minus infinity to plus infinity, integral from 0 to infinity, then also we have seen 0 to pi, then 0 to 2 pi, such types of integral. Okay, so in next lecture we will see another point of this unit.